My name's Andy Kerr. I'm the Director of Product Marketing and Communications at Bowers & Wilkins. We are here at our factory in Dale Road in Worthing on the south coast of England, where we produce our 800 series diamond range of loudspeakers alongside our flagship Nautilus range. We take in everything from the initial raw material, so the base level wood, the beech and the birch plywood that we use to form the fundamentals of the cabinet, and right from the start we're working ourselves. So we're cutting to size, we're doing everything from the layering up, the gluing, the bonding, the forming of the cabinet, pressing it into the correct shape, sanding it, preparing it, painting it, polishing it, getting it up to the appropriate standards. We're talking about a single layer of beech. That's the obvious thickness of that single layer, and as you can see by itself it's a very flexible thing. But of course what we're trying to do here is create stiffness in the enclosure of the loudspeaker. So to achieve that, what we do is A, use multiple layers, and B, use those layers in opposing grain orientations. So the outcome is a bit like an engineered wooden floor, in the sense that by building up those layers and opposing the grain structure, and with each additional layer that you add, the structure gets stiffer and stiffer. At this point here, what we have is the wrap form curvature coming out at the top in this particular case. So as you can see, if I invert it, you can see very clearly we've got that scalloping structure in shape. The next part of the process is to take this, to machine this away in the CNC, and to smooth that all out to create the part that can then be moved forward to become the top of the loudspeaker. So this is the matrix assembly assembled. What it now requires is the metal components that brace it up at the front end to make sure we're maximising the stiffness of the structure even more. And then what we can do is take this and slide it into the wrap form of the loudspeaker, which just requires a small tool called a spreader, which essentially grabs hold of the edges of the back of the loudspeaker and very, very slightly spreads it apart so that we can slide this inside. And then we can bond it all in place, close the loudspeaker cabinet back up, and we've got our complete structure. So what we're working on now is the machine polishing part of the process. This is that final stage of cabinet preparation, getting it ready before it goes down to our line for final assembly. One of the skilled operators working up here will work on this using the very high quality polishing materials that you'd use in automotive detailing. And the work takes as long as it takes, so depending on the size of the loudspeaker is kind of the primary judge. On a cabinet of this size, it's about an hour and a quarter of polishing very intensively, obviously on all surfaces as well. So one of the things we're working on here is the paint application process to the turbine head. The turbine head is the structural component at the top of the 802 that houses our mid-range enclosure. So it's a single piece of aluminium, very, very heavy, very stiff, very high mass. Because of its complex shape and its curvature, it's very difficult to apply the consistency of paint finish that we want to it using a machine. So instead we use hand process. We use one of our highly skilled paint trained guys who works purely doing this and nothing else within the factory. So the 802 D3 is the second to top model in what we refer to as the 800 series diamond range. It ranges from £4,500 a pair for a two-way model, a stand mount design called the 805 D3, all the way up to a very large flagship model called the 800 D3, which is £22,500. It's a large three-way loudspeaker, which I mean it has a dedicated bass section, a dedicated mid-range section, and a high-frequency pod on top of the product. This is the crossover. Think of it like the electronic brain, if you like, the filter of the loudspeaker. So the job of this component is to essentially establish which signal should be fed to which one of the drive units inside the loudspeaker. So the more drive units there are, essentially the more complex the crossover needs to be. Now it's our view that a simpler crossover produces a more effective outcome. A more complex crossover circuit will potentially run the risk of losing more of the original signal. So by keeping it simple, we can stay closer to the integrity of the original signal. That's a very straightforward way of doing it. We run a dedicated facility in a small town called Stenning, about 9 kilometres north of Worthing. And there are now currently 38 engineers and research guys working there purely on the art of developing and working on the most extreme ways to push loudspeaker design. We don't have any real constraints on timelines, we don't have any real constraints on process and effort there. They can do what they need to do. So that accumulative weight of experience and expertise is very fundamental to who we are and what we do. We actually really do believe in what we're doing, we really do like what we're doing. And that's fundamental, I think. If you're going to produce a product that you care about deeply and you have a passion for, it helps if you like coming to work each day.